Hi, Application Maths 2026, full solutions, all the data book questions, RStudio, Excel, everything you need. I've got it all here right now, and this exam was on Friday the 15th of May 2026 at 1 p.m. for 2 hours 5 minutes, unless you got extra time, of course. So now let's go through this and see how this paper actually was. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code Clelland Maths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code Clelland Maths to get 30% off that. Link down below. Hi, Application Maths 2026, question 1. David took out a personal loan for £3,000 on the 1st of July 2025. So this is a timeline question with loans. He'll start making the payments on the 1st of July 26 and the effective rates are in the table. So we need to set up a timeline for this. So let's just start with the 1st of July 25 and he put in £3,000. And then we'll move to when something changes. Well, it doesn't look like he's putting in anything else. He's took out a loan. Bit like putting money in the bank, same thing. So he starts making repayments on the 1st of July 26. The effective rates are as follows. So from the 1st of July to the 30th of September, 7.3. So I need to go to the 1st of October. And the effective rate is 7.3%. So that's 1.073. And then I need to count the number of months. So it's July, all of July, all of August, all of September is 3 months. So that's 3 out of 12. I never bother simplifying that. So now we go to the next time something changes. 1st of October to 28th of February, which is the same as the 1st of March, 26. That's 1.079. And the number of months there, October, November, December, January, February, but not March because it's the start of counting from, 5 out of 12. And then we have to go to the 30th of June 26, which is the same as the 1st of July 27 if you're counting this way. So 1/7/26. So then we have to go to the 30th of June 26, which is the same as the 1st of July 26. So from March to the 1st of July or 30th of June is 0.67% per month. Well done. So 1.0067. So how do I get that? Well, I do 100 plus 0.67, then divide by 100. So you can use a calculator for that anytime you want. And then since it's per month, the power is just number of months. So it's March, April, May, June, 4 months. So I've now set my timeline up. Since there's nothing else happening, I can just do a straight times and sum. So in the calculator, we're going to do 3,000 times 1.073 to the 3/12 times 1.079 to the 5/12 times 1.0067 to the 4. So let's get our calculator and work that out. Times 1.073 power bracket 3/12. Close your brackets, come back down. 1.079 power bracket 5/12. And 1.0067 power 4. I'm getting 3236.908, so that's 3236.91. And we're done there. Now, if you have done it as separate sums, that times that stop, then times that stop, then times that stop, you may find that you're rounding slightly off, but I don't think Qualifications Scotland will give you marks either way off either side, so I wouldn't worry too much. Qualifications Scotland, Higher Application Maths 2026, question 2. This is on PERT and Gantt charts. A company is repairing a house after a flood. The table shows the list of tasks required to complete the house repairs, the time required for each task, and the order is to be completed is shown in the table. Complete the PERT chart showing duration, the earliest start time, and the latest completion for each task. Just the usual then. So I need to find, my first task is A, none for 1. I think that's probably already done for us. No, it's not. So A and 1 goes in the middle. And then we've got like 1, 2, 3, 4. So I need to kind of go B, C, D, and E. I'm hoping that it goes in order and don't really want to think about it. If it doesn't, I will go back and just delete it. That's what I would do. So I'm just going to go B is 3. C is 21. D is 16. Like I say, if these are in the wrong order, we'll just go back and delete. E is 1. So that's that. And then let's just check what happens. F comes after B and E. So we can see that if F comes after B and E, F has to go here, which means that this one is in the wrong place. So that must be B for 3. So that one must be B for 3, which means the top one's probably D. It could be the middle one, but let's just do it. D is 16. So that's how I do these. I kind of just do it with trial and error, just instead of trying to plan a path too long, right? So we know that F is definitely in the right place. F is 2. So let's get the other ones in the right place. After D, D and H is J and K. So if that was D, then that's probably going to be H leading up to J and K. So I think D's fine there. So what about after C? After C is an F is G. After C and F is G, yep, that's working fine. And G is 4E. After G is H for 4. After H and D then, or D and H, we get J and K for 2 and 3. So that could be J and that could be K for 2 and 3. And then after H on its own, we've got I for 3. And there we are, a completed chart going forwards. And now we need to do our forward scan and our backward scan. So we put a 0 here and then we add 0 and 1 to get 1, 1, 1, 1. Now we do 1 plus 16, but we can't do that yet because that leads into J, so does H, so we need to check. So we'll actually go down a bit. We're leading into G. You can check if you're not sure, but leading into G is H. Leading into G, sorry, is C and F. So for C and F, we need to get F. So I'm going to have to actually start with B and E, which leads to F. So 1 plus 3 or 1 plus 1, I take the longest. 1 plus 3 is 4. 4, and then we can go into G by 1 and 21 or 4 and 2. Well, 1 and 21 is longer, so that's 22. So I think we've made this a little bit harder this year. 22 and 3 is 25. And then into J and K is either D or H. Well, H is longest for 29. And into I is just H as well. So that's 29. And then the complication at the end. To get your last, these three tasks are at the end. So I can either pick 29.2, 29.3 or 29.3. Well, 29.3 is 32. So 32 is definitely in there. But the mistake a lot of people are going to make is put 31 in J. No, it's still 32. Because we need to wait until the end. Now we'll do our backward scan. So our backward scan is taken away. So J and K lead into H, or I leads into H. So just they all are 32 take away 3 or 32 take away 2. You take the smallest, 32 take away 3 then is 29. So that's into H. And they're both the same. That'll be the same for D. 32 take away 3 is smaller than 32 take away 2. So that'll be 29 in D. And then going backwards from H, 29 minus 4 is 25. 25 minus 3 is 22, which leads into F and leads into C. And then 22 minus 2 is 20, which leads into B and E. And then we need to go back from there into A. We've got 4 options here, huge. We need to take the smallest of them all. Well, I can see that 22 minus 21 is 1. That's going to be the smallest possible out of all of them. So it's 1. And hopefully you get your completed one. So I think Qualifications Scotland will need that a little bit trickier because you're probably getting better at it. Okay, question B, construct a Gantt chart without float times for the house repairs. So you can either go down or up. I'm just going to go down. So starting at A at the top, then a little gap for B, then C, then D, then E, F, G, H, I, J. Does it go down to K, I think? K. So there's my tasks, and then I'll just check from the PERT chart. A starts at 0 and takes 1. That's the middle box. So you just draw a 1 in here. Little shade in is fine. Nice and neat with a ruler. B starts at 1 and takes 3. So end of 1, 1, 2, 3. Nice and neat box. C, 1 and 21. We're just checking each of these are 1s, yep. So the end of 21, if I can just see it, is here. So if I've done that right, that should be the end of 21. But you can obviously count it. In fact, it takes 21, so it will actually be another 1. Let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, so you can just shade all that in. Done. Now for D, 1 takes 16. 2, 4, 6, 8, 10, 12, 14, 16. I should be at the end of 17 then. Yep. So we shade that in, nice and neat, rulered. Obviously this takes a little bit of time. You can speed up the process, of course, in the video if I wanted to, but I wanted to show you the full thing. E is 1, 1. So end of 1 takes 1. It's just why there's no float time. It's going to become S with float time. F is 4, 2. So at end of 1, 2, 3, 4 takes 2. G, 22 takes 3. So if I find 22 on my Gantt chart, go up, that takes me to here. And that's to take 3. Just double check. Over line. Yep, end of 22 takes 3. H, end of 25 takes 4. So 22, 25. One, two, three, 4. And then we're on J, 29 and 2. Better do I first, actually. I, 29 and 3. So end of 29 for 3. End of 32, yep. K, 29 and 3. And J, 29 and 2. So there's J. And there's K. And there you go. I completed Gantt chart for that question. Not the nicest Gantt chart in the world, but there you go. Part C, state the float time to reinstate the bathroom, task J. So we've got some float time on task J. Why is that? Because some of these tasks end is when the finish time is at the end of day 32. That ends at the end of day 31. So it's just 1 day. Nothing special about that question. So we just write 1 day. There's nothing to really say. So we're done there. Qualifications Scotland High Application Maths 2026 question 3. Spreadsheet file Q3 tyres and the word processing document. You need to complete it all. Now it says the tyre manufacturer has collected data to investigate the relationship between the stopping distance meters and the tread depth millimeters of a new type of tyre. Oh look, construct a scatter plot just as predicted of tyre depth, distance on tread depth, correlation coefficient, and equation of a line of best fit, and estimate the stopping distance for a tyre with a tread depth of 6.2. So exactly what I thought was going to happen. Let's get going straight away. So I've already got this loaded in RStudio. This is a cloud version, but it works exactly the same. You go File, New File, R Script, and then Session set working directories, what you'd normally do if it was a desktop version, but on this one you can just upload it. And always the same, my data read.csv, q3 tires.csv. Make sure you've used the exact thing, and then attach my data. Now this year, Qualifications Scotland did allow you to have a data booklet digitally, so you might as well take full use. You have to do a scatter plot for part A, so you might as well just copy it, copy and paste. So you just go straight into there and copy it in, and then just edit your variables X and Y. So view file is called depth and depth. It wanted a scatter plot of distance on tread depth. So depth and depth, depth and distance, distance is Y, depth is X. So that's easy enough. So there you go, depth and distance. Scatter plot of this stopping distance on tread depth. I'll just type that in. X-axis label, or x-axis was tread depth, and we'll use millimeters. And our y-axis label is stopping distance. And stopping distance is in meters, I think. So I'll just put an M. Okay. So you should get something that looks a bit like that. Part B1 says find the correlation coefficient between stopping distance and tread depth. So correlation coefficient, again, you go down to correlation, it's a core.test xy. So core.test, back in your RStudio. X is depth, remember. And Y is distance. If you do that, you get a correlation coefficient, and we'll just start filling this in. Part A, statistical software output. So part A was the scatter plot, so I'll copy and paste it into here. If it makes it too big, don't worry, you can just fix that in the edit. I've not got anything at all. So there we go. Okay, nice. Now, statistical software output for part B. So that is everything that it gives us in the statistical software output. Let's copy that in. And then the answer, to answer what the correlation is, because it says find the correlation coefficient, it's minus 0.9864. It's that bottom number, minus 0.9864292. Or you can round it to about minus 0.99, say. Right? Part 2, interpret the correlation coefficient. Well, I can just do that straight here. It is a strong negative linear relationship between, and we're doing tread depth and stopping distance. Could say very strong negative linear relationship. Or correlation, if you prefer, between tread depth and stopping distance. I think that's all you would need for that. Interpret it. You could go on to say that that implies that as the tread depth decreases, stopping distance increases. But I think overall we're looking for is a negative linear relationship. Strong, if you can. Part C says find the equation of regression line. So if you go into your data booklet, there's two things. Ablin, if you put abline, it actually puts the line on, which I've actually done in RStudio for us, but it doesn't tell you the equation. What you don't need this bit, I just want to show you the difference. You need the equation just from LM. LM tells you the equation. So we LM y to the x. So y was distance and x is depth. That gives you some output. Let's copy that over to the Word document then. So our output is here, but we need to actually interpret that. So we've got our intercept and our depth. Y was the stopping distance. So stopping distance equals the intercept of 43.944 plus, but it's minus 2.376 times the tread depth. So that's the actual equation. Y equals mx plus c, but it's switched around is how I remember it because it's switched around in the RStudio output, so I don't need to think too much. First number plus second number times x. That's it. Question C says, estimate the stopping distance for a tyre with tread depth of 6.2. Now it does say statistical software output in here, so it implies you're going to do that, but you can actually do it without. But I'll do it with statistical software. So that's the predict command. So let's just copy that over and put it into our RStudio. So predict lm y to the x, so distance and depth. New data equals data.frame, x equals c. Depth equals, and the c number is 6.2 for this one. If you do that, it will do a bunch of stuff and give you an output. So from call lm coefficients, then underneath that, fit lower upper. Back to here, there's the output and the answer. It just says estimate the stopping distance. So we're just looking for a fit one. The lower and upper is a 95% confidence interval. So about 29.2 meters. And we're done there for that question. So you've just to print your document and where you go. But I'll show you the question one last time for your reference. So there was a whole question. Construct a scatter plot, find the correlation coefficient, interpret the correlation coefficient, equation of the regression line, estimate the stopping distance. Nice. Okay, Qualifications Scotland, High Application Maths 2026, question 4. It's a Venn diagram. As part of the recruitment process to become a firefighter, candidates must complete a verbal reasoning and numerical reasoning test. One day, a group of 140 candidates sat both tests. The results are as follows. 87 passed verbal, 75 passed the numerical, 42 passed both. Complete the Venn diagram. Okay, well, both is middle. So I've got 42 in the middle. 87 passed the verbal, so I need to do 87 minus 42, which is 45. And 75 passed the numerical, so I need to do 75 minus 42, which is 33. Then I need to find out how many are still missing. We must have failed then. So 45 plus 42 plus 33 is 120, but we started with 140, so 20 are neither passing anything. Part B of this question, one candidate is chosen at random from the group. Calculate the probability that this candidate only passes one of the tests. Well, we already know that the bottom number of this probability has to be 140 because there's 140 in the group. Passed only one test. Well, how many candidates pass one test? 45 and 33. So our top number is 45 plus 33. That's 45, 45, 55, 65, 75, 78 out of 140, which you can simplify, but I wouldn't simplify in higher applications of maths. 78 out of 140 is 0.5571. Or to times it by 100 as a percent, 55.71%. 55.7 will be fine. If you did happen to simplify this, 78 becomes 39 out of 70. And you probably should have simplified fractions for answers in maths usually, so that's why I would just change it to a decimal or percent. save myself simplifying. Although calculators nowadays do simplify anyway. Qualifications Scotland, High Application Maths 2026, question 5. Refer to the spreadsheet profit function when answering this question. And she owns a small business producing selling waxed candles. She wants to introduce a new scent for the summer. Her total profit is affected by more than just the selling price per candle. As production increases, the cost of storage, distribution, and promotions reduce the total profit. She used the following profit function to model her profit. So we're given a formula, right? S minus Cx minus 0.015x squared, where S is the selling price, C is the cost, X is the number of candles. Claire would like to produce 500 candles with a selling price S of £9. The cost to produce each candle, C, is £3. Open the candle profit worksheet. With the complete the candle profit worksheet to model how Claire's profit will change as the number of candles X increases from 0 to 500. Construct an appropriate graph to model Claire's profit. Right, let's go and see what we get on. Okay, so I've got this and I've loaded it up into Excel. I've put the question here just so we can refer to it as we go. But the first thing we need to do is selling price per candle S. Reading the question, she would like to produce 500 candles with a selling price of 9. So I'll just type 9 in there. Cost to produce each candle. The cost to produce each candle is £3, it says, so I'll put 3 in here. So now we need to construct a formula in these boxes for the number of candles and the profit. So you may or may not read down for this question depending on how Qualifications Scotland see it, but to be honest with you, it is money, so I am going around. We're just modelling how much profit will change anyway. So we'll write equals round as normal. You'll need a lot of brackets for this. So bracket for the round and then for the sum. So the sum I'm doing is S minus C. S is here, dollars, minus C is here, dollars. So that is to be times by X. So times X is over here. Then it's minus, so I need a bracket again, 0.015 times, and then it's B11 again to the power of 2 because it's squared. Close the bracket on that, and then comma 2 for the round, and then close the bracket on that, and that will give me my 0. And now I need to copy that down. So let's read the question. Complete the candle profit worksheet to model how the profit will change as the number of candles increase from 0 to 500. So we're actually going all the way down from 0 to 500. So we'll just copy. So we're going all the way down from 0 to 500. So I'll just drag that down. It should be set up for you. And there we are. So it's actually going into the minuses, which is fine. So we've modelled it. I think I'm quite happy with that. Construct an appropriate graph to model Claire's profit. Well, let's just highlight and go insert and then recommended charts. And it'll give us a graph. I think that's an appropriate graph to me. So that'll do. You could pick this one as well. I think I'll just pick the top one with the data points shown on it. And you would just put that in somewhere appropriate, maybe near the top. I'll just move the question to the side. And there we are, there's an appropriate graph, but always remember your axis titles, labels, stuff like that. So I'm going to add axis titles. So under the side, that is our profit in pounds. And on the bottom, I think that is number of candles. And a title, we could just write something like profit based on number of candles, or graph of profit in pounds on number of candles produced. Something appropriate, right? As long as you've got a reasonable title, a reasonable graph, a nice graph here, we're done there. Now let's look at the next part of the question by going back to the thing. But remember to just keep a note of what that graph looks like, right? We'll come back to it if we have to. We've done part A, 1 and 2. So part B says, state the type of model Claire was using. So there's two ways to know what type of model Claire was using. Look at the graph, it's curving up and then going down. So that's a quadratic, that's a parabola. The other way to tell is from the formula itself. From the formula itself, it has an x squared in it, and that's the highest power. If it's got an x squared as the highest power, it's a quadratic model. So that's literally all we need to say. So what type of model is using? Quadratic. The other types, remember, are linear and recurrence and exponential. We usually have recurrence quite often, but this is very similar to a recurrence question, just with quadratics. Explain what the graph shows when Claire produces and sells more than 400 candles. Well, let's have a look at our graph again. If we go down to more than 400 candles on the table, it starts to go negative, or the graph goes below the x-axis. She's got a negative profit. That means that she's losing money. So let's write something for that. So it shows a negative profit. In other words, a loss. I suppose we could say that once she produces more than 400 candles, she starts to lose money. So if we look at the question, as production increases, the cost of storage, distribution, promotions reduces the total profit. So once she produces more than 400 candles, the cost to produce the candles is more than the selling price. Now, I don't think I need as much as that because it is on a rough mark. I think just it shows that she's making a loss after 400 candles will be more than enough for that question. Okay, part 3 says, state how many candles Claire should produce and sell to maximise her profit. Well, let's go back to our spreadsheet. So looking at the spreadsheet, we're looking at the point where it is the maximum number. You should be able to see the maximum number is 600 at a profit of 200. You don't have to be able to do quadratics to do this. You can see here as well, 200 candles gives 600, then it goes down again. So 600 is the maximum. So she should produce 200. And the command word here is state, so you just get a mark for saying 200 candles. That leads to £600 profit, I think, but it's not asking for that. I'm just taking a note just in case we need it. To produce each candle, Claire pours wax into a mould in the shape of a cuboid. Each mould has a length of exactly 3 centimetres and a breadth of 4 centimetres. Claire pours the wax to a height of 7 centimetres with a relative error of 2%. Calculate the absolute error in the volume of a candle. I've predicted this would come up this year. Very simple one just to get you into relative and absolute. Relative means a percent or a fraction. So that means that the absolute error in the height, because the other two it says is exact, is 2% of 7 centimetres. Well, 2% is 0.14 centimetres. Now there's one, you could be tricky here and say that since height is proportional to volume, you're done and it's 0.14, but I'll probably show you the way you would do it. So volume equals length times breadth times height. 3 times 4 times 7 is the exact volume. So exact volume is 84 centimetres cubed. And then we could say, well, what is the minimum and maximum volume? So the min volume is 3 times 4 times 7 minus 0.14, 6.86. Which is 82.32. And the max volume will be 3 times 4 times 7.14, which is 85.68. So that means that as a tolerance, the volume is equal to 84 plus or minus, well, 85.68 minus 84 is 1.68. And it'll be the same either side because it just went up or down by the same amount. 1.68 centimetres cubed. So the absolute area in the volume of the candle is equal to 1.68 centimetres cubed. And we're done there. However, I think you could have got there a lot quicker, by the way, because since the length and the breadth are fixed, the height is the only one that's changing. So if you change the height by 0.14, then, or 2%, then the volume must change by 2% as well. So I could have just done 2% of this volume, and I'll show you, you'll get the same answer. 2% is 84, 1.68 centimetres cubed. So there you go. That's what I probably would have done. But I thought I'd show you the way that a lot of people would do it in school. And just in case you don't know what Qualifications Scotland are going to actually say, but I've got a feeling you'll get a mark for working out 0.14 and then a mark for getting 1.68 either way. Just to note at the end, print the candle profit worksheet in value view and formula view and show your graph is positioned beside the table on one page. So let's just have a look to see what we do, because it's quite important we can actually print our stuff when we get rid of the actual question. So beside the table it says on one page, so I'll just drag this down a wee bit. That looks good. Now, just file, print as usual. One page, I want contained. If I wasn't, I would go down and try and change it. See, if I've got no scaling, I get 4 pages. I only want one page, so fit sheet on one page. Now I want formula view, formula, show formulas. So now look, you can see all your formulas. So that means it can actually mark your stuff, right? So file, print again, and again it wants one page. So make sure you've clicked fit sheet on one page. Scaling is not what you want, because you end up with 6 pages. That's the problem. You want fit sheet on one page so that you're not printing out 50 pages later on or anything else. And we're done there. Qualifications Scotland, High Application Maths 2026, question 6. Natasha owns a savings account. The annual effective rate of interest is 1.5%. It's paid at the end of each month. Find the monthly. Remember, for monthly, you do not divide by 12. You do 1.015. So I'll add 100 and divide by 100. And I want the power is 1 over 12. 1 month out of 12 months. So calculate a job for that. Now, before I actually do the calculator job, I'll just show you actually. 1.015 to the power over 12. Now, the problem with this is that's not a percent, that's 1.001. So I need to take away 1 and times 100, right? So I'll write down what that is, 1.001241. So I need to take away 1 and times 100 to get it back to a percent. And never round, minus 1 equals times 100 equals 0.124%. I've done it to 3 decimal places. I think 2 would probably be fine, 1 wouldn't. So I'm going to use 3 decimal places when I do my question next, but you can maybe use 2. Natasha will make an initial deposit of 1,000 into the savings account on the first day of July. 1 month later, and every month after that, she will deposit 150 on the first day of each month. Complete the savings schedule to calculate Natasha's savings account balance immediately after making her second deposit. So we've got this type of table, the usual type. So time in months, 0, balance 1,000, because she put 1,000 into the savings account. 1 month later, she will deposit 150. First of all, we're going to work out our interest using the 0.124%. So for my working, I don't need any, but for the first interest, I do 0.124% of 1,000. The deposit we're putting in is what I'll type in is 150. And 150 there. Immediately after making our second deposit. Right, so there we are. Calculator. 0.124 divided by 100 times 1,000. £1.24. So she's earned £1.24 in interest. She's made a deposit, so our balance will be made up of the interest earned plus the deposit plus the balance. So a little bit different than normal, but nothing out of the ordinary really. 115,124. And then I start again. So I need to do 0.124 0.124% of the new balance, which is this. Calculator, 0.124 divided by 100 times 1151.24, £1.427, £1.43, then we'll round up. We'll put 150 in, so we just add up. 1151.24 plus £1.43 plus 150, 1302.67. And that's it. We're done there. Complete the savings account to show immediate after a second deposit. Fantastic. Okay, Qualifications Scotland, High Application Maths 2026, question 7. A university student wants to answer the following research question. Is there a significant difference in the mean time taken to run 100 metres between pupils aged 10 and pupils aged 12? The university selects a random sample of pupils between 10 and 12. They then record how long each pupil takes to run 100 metres. State the appropriate hypothesis test to investigate the research question. Okay, so there is, for this type of question, it is a t-test. Okay, it's a two-sample t-test. It's unpaired as well if you want to be really technical about it, but I think a t-test would be actually just all you would need. But I'll be really specific. It's a two-sample t-test, and I'll write in brackets unpaired. But to be fair, I think the mark is for t-test. Okay? State the null and alternative hypotheses. The null and alternative, right. In theory, we should all be able to do this because we've all done a project, but let's see. The null, sometimes called H naught, is there is no significant difference in the mean. What is it about? The mean time taken to run 100 metres. The mean time taken to run 100 metres between 10 and 12-year-olds. I'll probably write between 10-year-olds and 12-year-olds, so it's really obvious. Okay, and then the alternative hypothesis. There is a significant difference. That's the only difference. There is a significant difference in the meantime taken to run 100 metres between 10-year-olds and 12-year-olds. So just the standard statement. No difference, a difference. It's about the mean for this one. Okay, part B. The hypothesis test was performed in generating a p-value of 0.072. Interpret the p-value and the result of the hypothesis test in context. Now remember, if it's less than 0.05, you can reject the null hypothesis. But if it's more than 0.05, you fail to reject the null hypothesis. You've never accepted it. So p of 0.072 is greater than 0.05. Fail to reject the null hypothesis. So that means that there is insufficient evidence to conclude that, let me just state the null hypothesis again. There is a significant difference in the meantime taken to run 100 meters between 10-year-olds and 12-year-olds. Now, it's a little bit nuanced, this question. So, fail to reject a null hypothesis. You can't accept it because it may well be that there is a difference. It's just that this particular data doesn't actually give you anything, right? So there is insufficient evidence, or there is not enough evidence to conclude that there's a significant difference in the mean, okay, based on this. Qualifications Maths 2026, question 8. You must have deductions on salaries and mortgage products and affordability given in the previous material, as predicted. You must fit the spreadsheet Janet's mortgage, and you must complete part B using the spreadsheet, part A and C in the space below. Okay, so part A, Janet's gross annual salary is 32,100, 3% of her salary before tax into her pension. Janet pays 13016 in national insurance. Calculate the net monthly income. Right, so here is the tax table from the start of the exam paper. So all we do is do it bit by bit. It's a gross annual, so £0 for this bit, and then we go on to 15,397 minus 1257 times 0.19. However, do not forget the pension. Pension comes up before tax. It even tells you in the question in this one. So let's work out our pension first. %3 of 3,200 is 963. So our taxable pay is 32,100 minus 963. 31137. We'll just watch out for that because that's as high as we can go for tax. So now we just do our table bit by bit. So we've got 15,397 minus 12,570 times 0.19. It's 53713. And then 27,491 minus 15,397 times 0.2, 241880. And then finally, we're in the band because it goes up to 43,662. So I need to use 31,137. So 31,137 minus 27,491 times 0.21. And we get 76566. So the total tax, we can just add them up. 53713, 2418.80, 76566 is 372159. So there's my tax. We've already got our pension. Now, the national insurance is quoted monthly. You could take everything off and divide by 12 and take off the national insurance. I prefer to do everything annual part and then divide by 12. It's just me. So the tax for that's the annual tax. Annual national insurance is 130.16 times 12, 156,192. So net pay annually is equal to, well, I've already took the pension off, so 31137 minus the tax minus the national insurance and you get 2585349. So that means the net monthly is that divided by 12. $215446. And we're done there. Okay, Janet is applying for a mortgage of £98,000. Level repayments are made at the end of each month. The fixed annual effective rate of interest is 5.4% for the first 2 years. She would like her mortgage balance to be no more than £93,000 at the end of the fixed rate period so she can reduce her loan to value ratio. Part B, complete the mortgage repayment schedule to determine the minimum level monthly repayment amount required. Then determine whether Janet's mortgage lender would consider this amount affordable. Give a reason. In other words, you should start the exam paper to the 28-36 rule. So let's look at the actual spreadsheet first for Part B. They're given a spreadsheet, initial loan amounts already filled in, annual, straight away, jump into monthly. So to work out your monthly is equals 1 plus the annual to the power of 1 over 12 minus 1. Just the usual stuff, right? Monthly repayment, no idea. So I need to put a monthly repayment in. And what we try to do, Part B says she wants to reduce her balance to be no more than 93,000. Let me just show you that here. She wants to be no more than 93,000. I'll delete that later, just so we know. So we're going to goal seek in a minute, and usually we goal seek to 0, but in this case it's just to 93,000. So the difference. So we just guess a monthly repayment. I'll just guess 500. It doesn't matter. Make sure you don't type equals 500 or nothing will work. 500. Right, repayment. That equals our guess. That's outside the table, so you need dollars. Our interest is always rounded, equal round. So our interest is our monthly effective interest, that's dollar because it's outside the table, times our mortgage outstanding. Comma 2, now mortgage outstanding is inside the table, no dollars. Our capital is our repayment minus our interest. And our mortgage outstanding is our mortgage outstanding minus our capital. So just like that, as per normal. Copy that down to the 24 months. We've not even had to work it out. We've done that for you. But now that's 96,243. I want 93. So I'm going to goal seek that. So it's data, what if analysis, goal seek, change that to 93,123 by changing cell, well, what we actually guessed. So it runs a little bit of thing, press OK. Oh, 62845. There's no real change. Usually we change stuff at the end and all that stuff. There's none of that here because we're not actually bothered, right? You could change that to 64845 and then change everything, but we're not bothered about like it being at 0. So as long as we've done our goal seek, I think that question's done. Just the minimum level monthly repayment amount required. There's one thing. If I make this 62845 and delete that, what will happen is it'll change it to, it does still say 93,000, but I would question whether or not that actually was 93,000. So I would actually say it's 62846 because it was a bunch of decimals. So 46 I think would be my answer to get it to at least 93,000 or just below. And we're done there. So our answer was 62846. Determine whether the mortgage lender would consider this amount affordable, give a reason. Let's have a look at the data booklet. If you take out a mortgage, you've got a loan to value ratio. We've not been asked to work out the loan to value ratio, so we don't really care. We're about affordability here. We use affordability from this 2836 rule. Borrowers and lenders must consider affordability. No more than 28% of taxable monthly income should be spent on housing loan costs, mortgage payments. And then the 36 rule is about taxable monthly income, but also debt, loan repayments out alongside mortgage. Well, the question doesn't mention any of that, so it must only be the 28% rule. So if I look at the 28% rule, examining the 28% part, no more than 28% of taxable monthly income housing loan costs. So 28% of the taxable monthly income we worked out way back up here. Well, taxable pay is 31137. So taxable per year was 31137. So per month, we can divide by 12. Is 259475. So we just do 28% of 2594.75. So that's 0.28. 2594.75 is 726.53. £726.53, but we just worked out that we need to complete the mortgage. The minimum level she needs to pay is 628. So she's got up to 726.53. So is it affordable? Yes. It's is it called affordable? Yeah, affordable. Yes, affordable as 62846 is less than 72653, so it passes the 28% rule. Although we don't know about the 36% part, we'll probably take into account all the other stuff as well, but for this particular question, that is it. In this bit here, I've erred on the side of caution and made it 62846. It could be that it's 62845, and they're fine with that, but I've just erred on the side of caution, so just don't worry too much about that last little bit. Okay, so Maths 2026, question 9. A company has won a contract to manufacture and deliver a new flooring for a new housing development. If they fail to supply a flooring in time, they have a penalty of 120,000. So this is going to be control measures, obviously then. Two reasons for a possible delay. Manufacturing delay, 0.25% there's a delay in the manufacturing. Delivery delay, 0.15. Probability there's a delay while the company delivers the flooring. Complete the missing probabilities and complete the tree diagram. Interesting, I've done it this way, but that's exactly how you should be doing it anyway to work out what's the chances of something going wrong or not. So if your teachers have been like just missing that out, this might have been gobbledygook to you, but you shouldn't just be skipping ahead. You should be doing things in a nice structured way. So the probability of a delay is 0.25. It needs to add up to 1, so it's 75. Nice and easy. The probability of a delivery day is 0.15. It needs to add up to 1, so that is 85. We know the delay is still 0.15, no big deal. So it's 0.85 still down here. And then to get your probabilities at the end, for really led you through this, you times across the branches. So it's that times that. So I'll just get that, 0.25 times 0.15, 0.0375. The next one, I go along and down, so 25 and 85, 0.2125. And then I go down and up, so 75 and 15, 0.1125. And then down, 75, 85, 0.6375. That all have to do for part A1? Yeah, that's it. We're done there. Part 2 says, determine the probability of one or both of these delays will happen. So, two ways to do this. You've got to all these probabilities. So one delay or both delays, well, there's both that one. One delay that way is this one. No delay and one delay that way is this one. The only way to get no delays is that one. So there's two ways to do this. These add up to 1. So that's why you could just do 1 minus that, and that would give you it. Or you can just add up the 3 you've got. It's either way is fine. I'm just going to do the add bit because I went to trouble working them out. 0.0375. 0.2125 and 0.1125, or you could have just done 1 minus 0.6375. So you get 0.3625. Part 2, hence calculate the expected cost of a delay. So the expected cost is the probability of a delay times the penalty, which is 120,000. So 0.3625 times 120, 123, is 43,500. And now we move it to the control measure part. The company is considering using the following control measures. Control measure 1, hire additional staff to help manufacturing the following, cost to £20,000. Control measure 2, hire an external delivery company to deliver, cost 12,500. Calculate the expected cost of only control measure 1. Well, control measure 1 straight away costs £20,000, but then we've left with the probability for control measure 2 still not being in place. So if we go back to our probability tree, we've now eliminated essentially the manufacturing delay. So the only thing is left, we don't need to worry about any of that, is the delivery delay, or you just go back up to the question. Manufacturing's out, so there's a 0.15 chance of delivery times 120,000. So we just work that out. £38,000 I get. Then control measure 2 price. Well, the control measure 2 price is 12,500 plus, now we're still left with a probability of that failing. So control measure 2 is all about the delivery, so that's out. So we've still got a manufacturing delay, 0.25 times 120,000. £42,500. So £38,000 to use control measure 1, £42,500 to use control measure 2, and a £43,500 for just expected cost of delay with no control measure. The company decides to use both control measures. Based on your calculations, explain why the company decided to use both. Well, let's examine what happens if you use both. If you use both control measures, without any probabilities, it's 20,000 plus 12,500. That's £32,500. The expected cost with no control measures of a delay was 43,500, so it's less than that. If you only use one control measure, the expected cost was at a minimum 38,000 and a maximum 42,500, but it's still less than that. So by using both control measures, the probability of delays drops to 0, and that means that the cost would just be the 32,500. You wouldn't add any of the probabilities in, which is less than the expected cost of using one control measure or no control measures. But it's still about expected costs. And there we are. So it's cheaper, expected at least, to just pay £32,500 and just do it properly. There we are. Okay, Scotland Applications Maths 2026, question 10. Deirdre bought a van using a finance deal. As part of the deal, she must make a final lump sum payment. The lump sum payment of 8,175 is due in 3 years' time. To budget for this, Deirdre will make a single deposit into a savings account with an effective rate of interest of 7.1%. So this is a present value question. Calculate the minimum amount Deirdre must deposit to ensure she has accumulated 8,175 when the payment is due. So she wants 8,175. So it's 8,175. I'd usually times by, but I'm now dividing by 1.071. And how long is it? 3 years' time. So the answer to that sum is 6654.560056. So 5, 6 with a bunch of other numbers. If I just put 5, 6 in, I'll be slightly short. You can see this by if I just get rid of that and go 6654.56 times 1.071 to the power of 3. I've not really got 8175. It rounds to 8175, so I probably would. But I would say the answer really should be 6654.57. But I think I'll get away with 5, 6. You never know. So 6654.56 with a tiny and minor amount of numbers. So really the minimum amount she has to ensure to accumulate at least 8175 must be 6654.57. But I think 5, 6 should really be fine, really, if you think about it, because it rounds up to 8175. He says in June 2021, when Deirdre bought the van, the consumer price index was 111.4. After 3 years, it was 113.0. Determine whether Deirdre's savings has increased in line with inflation. I've got the difference in the inflation divided by the original inflation, tells me what percentage increase we should have. So 11133 minus 111.4 divided by 111.4 is 0.1938, which times 100 is about 19.4%. So inflation is at 19.4%. Now, what about her savings? Well, it's not just 7.1%, it's 7.1% accumulated per year, 3 years. So I can compare it by doing a few things. I could do 19.4% of the deposit and add it on, or I can just take the inflation. Well, let's just do it both ways. Let's do it that way. 19.4% of will give us 1.194 times 6654.57, which is 794556. But we know that her savings went up to 8175, which is above. So has Deirdre's savings increased in line with inflation? Increased above inflation. Because 8175 is greater than 794556. The other way you could have done it is took the interest rate into account, which is 7.1%, and done take away 1 and times 100, and you would realise that her savings have went up by 22.8%. Or the other way you could have done it, one last way to cover all bases, is we could have worked out the percentage increase from 8175 from 6654.57. And that would give you the same idea. It's giving you the same percent. But either way, we're done there. Deirdre's insurance policy has a £195 excess for accidental damage. Her van though is damaged by an accident. The company is quoted to an intent to repair the damage. Give one reason why Deirdre may not make a claim on her insurance. So the difference in the excess and the repair is only the insurance will only pay £210 minus 195, which is £15. But by claiming, she may lose no claims discount. That's one option. The other things that could happen is that her future premiums could rise. Future payments could rise perhaps more than £15. It costs to repair, or it's not even worth filling in the paperwork. Anything that sounds reasonable and is sensible for this question, but I think that's the most common ways to answer it. Qualifications Scotland, High Application Maths 2026, question 11. You must refer to information on honeybees in the pre-release material. Each year the national hive count takes place. During the count, all UK beekeepers are asked to submit the number of honeybee hives they own. The following data was collected. So 2019 to 2022, number of honeybee hives. State one reason why this data might misrepresent the number of honeybee hives in the UK. So each year the national hive count takes place. All UK beekeepers are asked to submit the number of honeybee hives they own. So it could just be that it misrepresents the number of honeybees because it relies on self-reporting. We're just asked to report, we're not made to, it's not a law. So it might be that some choose not to fill in the survey. Also, I think it misses people like amateur honeybee hobbyists. So another option could be that it disregards hobbyists. It might disregard hobbyists that are unregistered. Something like that. Something to do with it doesn't capture everybody, in other words. 11 continued. From 22 to 23, there was a decline in approximately 36,000 beehives. A newspaper published this graph with the headline, "No honeybees in the UK in 2031. Explain this why this headline might be misleading." Okay, so just another quick question on this. So we're seeing a steep decline between 22 and 23, but they're extrapolating over a number of years. Populations don't do that, generally speaking. Things could happen, it'll intervene. So because something happened over 1 year does not make it happen over 10 years. So it assumes the decline over 1 year, 22 to 23, will keep happening. But that is unlikely, as something like populations usually plateau, or any reason you can think of. Humans may intervene. Lots of things. Anything to do with, it's unrealistic for that trend to keep going because we don't know what's going to happen in the future just because of what happens over 1 year. Question C, it takes approximately 17,000 bees 1 month to produce a jar of honey. Estimate the weight of honey produced in the UK in 2022. Stating the assumptions you've made. So I've put the honeybee information down below us so we can refer to it. So the first thing I can see is that a colony will have no more than 100,000 bees. So let's assume a colony has, let's say, 70,000 bees in. Anything less than 100,000, but not too small. Let's also assume if it's in a year, do we produce honey every single month? Probably not. Let's assume produce honey for 6 months per year. Okay, so we've produced that, and then the size of a jar of honey, well, I don't know. Assume a jar weighs 500 grams, say. And for 2022, so how many colonies have we got? Well, it doesn't, each year the National Beehive took count. State one reason why it misrepresent. So it might have misrepresented it, but we're just making an assumption that 288,311 is fine. So assume 288,311 colonies. Just form the question. Right, so let's look at one colony then. Question says 17,000 honeybees to produce. A colony we're saying has got 70,000. So 70,000 divided by 17,000 is about 4.12 jars. So then to get our total weight for a year, we need to use all our assumptions. So 4.12 jars times 500 grams a jar times 288,311 colonies, and that's for a month, and we're going to go for 6 months. So that gives us 3,563, 523,960. Or about, take away 3 zeros, 356,352,4 kilograms, or in other words, anywhere between 3 and 4 million. 3 to 4 million kilograms. Because it's 3, 1, 2, 3, 4, 5, 6. Now, my assumption is based on assumptions, right? I assumed that, let's make the colonies what it said in the question. I assumed the jar was 500 grams. I assumed it we're producing 6 months a year. I assumed 70,000 bees. As long as your assumptions are based on the question and based on the data booklet and are reasonable, so you don't say a jar of honey weighs 1,000 kilograms, then you'll get the marks, okay? Same way with production. You don't know anything about bees, you might have said bees produce for the whole time. Again, it's whatever's reasonable, you'll get marks for. Hopefully that makes sense. And this will be Clelland Maths today. We've done Higher Applications of Maths 2026. Hopefully you found that useful. Let me know in the comments how you got on. Take care, stay safe, and I'll see you soon.